Hello everyone, I am Varun, Assistant Professor, Department of Mathematics, SJB Institute of Technology. Hello everyone, continuing our numerical method session. Today we will be addressing the last portion of numerical methods, which is numerical integration. The formal definition of numerical integration and related formulas is already posted. Only the formulas which belong to your syllabus, Simpson's 1/3 rule, Simpson's 3/8 rule, and Weddell's rule have been posted. Hope all of you have noted it. So we will directly look into the problem solving part today. So keeping that in mind, we will take up our first problem. Evaluate a definite integral 0 to 1 by 1 plus x square dx by taking 4 equal strips and hence deduce an approximate value of pi. The important thing here is most of the time you will be given an integral and you will be told which formula needs to be applied, but here nothing is told. Okay, that's first thing, first observation which we are supposed to make. And second thing is here we have been also told to find an approximate value of pi. So our first job is whichever function is given inside the function which has to be integrated, we will concentrate on that. Okay, and we will write that function as f of x. Okay, from the integral we made an observation that 1 by 1 plus x square is f of x. And second thing is they have specifically told us that we are supposed to take 4 equal strips, or we are supposed to divide the interval 0 to 1. Okay, observe here, the lower limit is 0, the upper limit is 1. So in between the interval 0 to 1, we are supposed to divide into 4 equal parts. Okay, that's the concept. So with that in mind, to divide the entire interval 0 to 1 as 4 equal strips, we are supposed to take n is equal to 4. Okay, understanding? So in the next stage, in formulation we saw one thing like the last term xn is also represented as x naught plus n into h. Okay, with that I can also write, I'm just shifting this x naught to the other side, so it becomes nh is equal to xn minus x naught. In the next stage, h will be equal to xn minus x naught divided by n. Obviously, here xn, the last point in the given problem, it is the starting point is 0, the ending point is 1, because we are considering the interval as 0 to 1, right, in the integral. So the starting point x naught will be equal to 0 and the ending point, the upper limit, is xn. So with that I will write it as 1 minus 0 divided by n, because we are supposed to divide it as 4 equal strips. Okay, n will be equal to 4, and obviously 1 by 4 value is 0.25. One thing which I would like to highlight here is h is equal to 0.25. That h, in our formal definition we saw the h stands for step length. Okay, it plays a very, very important role. We will see how, in what way it is important in the next stages. So with all these data, okay, as I told you, the first value, the lower limit of the integral is 0. We will take that as x naught. Okay, then yes, previously we saw a formula xn is equal to x naught plus n into h. Now I am substituting n is equal to 1. So when I substitute n is equal to 1, xn becomes x1, which will be equal to x naught plus n value is 1 into h. Getting it? Which will be equal to, of course, x naught value is 0. X naught value is 0 plus h value is 0.25 into 1 turns out to be 0.25. So our x1 value is 0.25. Getting the logic? So in the next stage, replacing n is equal to 2, the same formulation becomes x2 is equal to x 0 plus n into h. In place of n, now I have 2, right? Which will be equal to x 0 is 0 plus 2 into 0.25, right? 2 into 0.25 is 0.5. Agree? So x2 value is 0.5. In the similar way, x3 value will be 3 into 0.25, which is 0.75, and x4 will be 4 into 0.25, which will be 1. And we already know one thing, that 1 is actually our last point. So the moment we get xn, we will stop our division. Okay, right now we divided the entire interval into 4 different parts. Of course, 0 to 0.25, 0.25 to 0.5, 0.5 to 0.75, 0.75 to 1. So on the whole, 4 equal strips have been made. But one thing you must observe here is we have 5 different points. Understanding? And every time our first point starts from x0 and it is not x1. Getting it? Right? So with all these data, in the next level, the moment I know what is the value of x0, x1, x2, x3, x4, I will start substituting that to the given function f of x, just to make sure I get the points y0, y1, y2, y3, y4. Of course, y4 will be yn. Okay. So if f of x or y is equal to 1 by 1 plus x square, okay, then I can obviously write y0 to be equal to 1 by 1 plus x0 square. So substituting the value of x0, I am getting y0 to be equal to 1. So in the next stage, substituting the value of x1, I will be getting 1 is divided by 1 plus 0.25 square. The value of that is 0.9412. Okay. Similarly, y2 will be equal to 0.8, y3 will be equal to, okay, one thing you must be clear. When I am talking about y2, I am substituting the value of x2. Right? When I am talking about y3, I am substituting the value of x3. Then I am simplifying the given function, and that is giving me y2, y3 respectively. Getting it? So the last values, as we know, yn will be equal to y4, so which is 1 by 1 plus 1 square, which is 0.5. So with all these datas, okay, now I know one thing, that x0 is equal to 0 and corresponding value of y0 is 1. x1 is equal to 0.25 and its corresponding value y1 is 0.9412. x2 is 0.5 and its corresponding value y2 is 0.8. x3 is 0.75 and its corresponding value y3 is 0.64. x4 or xn, okay, the last value is 1, and of course its corresponding value y4 or yn is 0.5. I have a reason to mention the last point as yn than y4, and in the next stage we will be looking into that also. Okay. Of course, we know that n is equal to 4 and n is equal to 4 is a multiple of 2. So in the previous notes, we have clearly mentioned one thing, that when n is multiple of 2, the formula is Simpson's 1/3 rule. Okay? When n is a multiple of 2, we are applying Simpson's 1/3 rule. And it says I is equal to h by 3 into y0 plus yn plus 2 times y2 plus y4, so on yn minus 2 plus 4 times y1 plus y3, so on, plus yn minus 1. It's quite easy to remember. Let's analyze this for the given problem. Now I have the same formulation, and of course I'm writing all the data which we got after simplifying the given function. Okay. What I want everyone to observe here clearly is in the first stage I have h by 3, h value is already known, it is 0.25 for this problem. Okay. Y naught will be substituted first, yn will be substituted next, getting it? Then I have 2 times y2. Okay. Then 4 times y1, y3. Now, of course, one might be thinking like, why did I skip this term? Okay, dear students, one thing you must observe here, y4 is our yn, and it is already used in this term. So every term will be used only once. We need not repeat it again. Understanding? In a very simple way, this formula can be remembered. So when they say Simpson's 1/3 rule, one can make out that h by 3 is nothing but 1/3. Then this is common in both the formulations, y naught plus yn. Right? Then 2 times all the even numbered term. Did you see that? All the even numbered term. By chance, if I have 6 terms, for example, if I had y6, okay, with 7 ordinates, I had y6, then I would have got both y2 and y4 here, and yn is equal to y6 would have been substituted here. Understanding? In this problem, it is only till y4. When that is the case, I am supposed to consider only y2 multiplied with 2. In the next stage, 4 is multiplied with all the odd numbered terms. y1, y3, if it exists, y5, y7, y9, all those terms are substituted here. Understanding? So, the moment you remember the formula, it's a very, very, very simple problem, because we will rewrite the Simpson's 1/3 rule for n is equal to 4. Now what happens? As you know, in the second term you are having only y2. In the last term it is 4 into y1 plus y3. Of course, in the first term you have y0 plus yn. Right? So we will rewrite, first we will write the general formula, then we will rewrite for n is equal to 4, the particular case of the given problem. Right? So after that, we will just substitute all the values of y0 to yn, whatever value we got, we will substitute all that. By simplifying that, I am getting the value of I to be equal to 0.7854, and that's our value of integral from 0 to 1 by 1 plus x square dx. The value of that integral is 0.7854. In fact, if they ask you only the integral value, this is our last step. Understanding? If only integral value is asked by numerical integration, then the value after substitution and simplification, whatever value we got, that's our final answer. But as you know, in this problem, we have another task. The second part of the question says, hence deduce the approximate value of pi. Okay, so for that sake, we will extend this problem. As you know, by direct integration of 0 to 1 by 1 plus x square dx, we will be getting, of course, 1 by 1 plus x square integration will be tan inverse of x, right? Tan inverse of x within the limit point 0 to 1. In the next stage, upper limit minus lower limit, I will be getting tan inverse of 1 minus tan inverse of 0, which will be tan inverse of 1 value is pi by 4 minus 0, which is tan inverse of 0. Okay. So the integral value will be equal to pi by 4. Now, when I is equal to pi by 4, it obviously means that pi will be equal to 4 times I. Just cross multiplying it, I am getting pi is equal to 4 into I. And over there, I will substitute the value which we got after simplification, right? So pi is equal to 4 times 0.7854, and the value is pi is equal to 3.1416, which is approximate value of pi. Agree with this? So this was the solving procedure of our first problem. Hope you liked it. Okay, and it's very important question. Okay, and it's important because you also have hence deduced part in it. Continuing with this, I have another interesting problem, and the problem is given by find the distance traveled by a train between 8:20 a.m. and 9 a.m. from the following data. Okay, so of course 8:20 a.m. to 9 a.m. it's around 40 minutes. Okay, and okay, we can see the speed is given in miles per hour. At 8:20 the speed was 24.2 miles per hour. At 8:30 it is 35 miles per hour. At 8:40 it is 41.3 miles per hour. At 8:50 it is 42.8 miles per hour. And at 9 o'clock, okay, it is 39.4 miles per hour. Now the interesting part here is one can easily observe the timings, the readings taken in 5 different timings. Okay, they are equidistant. Okay, the difference between them is 10 minutes each, right? 8:30, 8:20 to 8:30 is 10 minutes, 8:30 to 8:40, 8:40 to 8:50, and 8:50 to 9 o'clock. All are within the time span of 10 minutes each. So in the next stage, yes, we will the distance traveled, we will take it as we will denote it by s, small s, and the speed is also known as velocity, so we will denote it by v. Okay, in physics it says rate of change of position with respect to time is velocity. Okay, and mathematically it is v is equal to ds by dt, right? It's a simple concept of physics. So this also implies me that s is nothing but the opposite of differentiation, integration from t naught to tn, the starting time point to the ending time point. Okay, for v, agree with that? If v is differentiation of s with respect to t, then v will be obviously, then s will be obviously integration of v with respect to t within the time point or time limit t naught to tn, the starting time to ending time, right? So with this logic, since we have 5 different values of time, it obviously implies me n will be equal to 4, because the first term is taken as t naught, okay, then t1, t2, t3, t4, okay. So the last value is t4, that implies me n will be equal to 4. This is very important and interesting. The thing is, the time interval we saw it is 10 minutes. The difference between any two time, any two consecutive time given to us was 10 minutes. Same time, The other data given to us was the speed in miles per hour. Okay, so we are bound to have a common dimension. One side we know that 10 minutes is the time difference between two consecutive timings, and on the other side speed is given with respect to miles per hour. When it is hour, we are supposed to convert this minute in terms of hours, just to make sure when we apply in formulation all the y terms, all the velocity terms is substituted, they are representing miles per hour, and on the other side h should not be in minutes, even that has to be in terms of hour itself. So we know 10 minute is equal to 1 by 6th of an hour, so h will be equal to 1 by 6. So of course all the data given to us in the table, all the speed data is given to us, we will represent it as v0, v1, v2, v3, v4, which is of course vn. Okay, we already know all of them are in miles per hour. So yes, this is quite obvious. Here n is multiple of 2, of course n is equal to 4 and 4 is multiple of 2. So we are bound to use Simpson's 1/3 rule. And for this problem, it turns out to be S is equal to, of course, here it is not I, you already know S represents the distance traveled, and in calculus wise we saw S to be equal to T naught to Tn, integral from T naught to Tn v dt. So here we are not representing integral as I, we are representing it with S, small s, to be equal to h by 3. Okay, v0 plus vn 2 times v2 plus 4 times v1 plus v3. This is already explained in the previous problem. The logic is explained. The only change which you can observe here is earlier it was y. Now you know those points are velocity points, so we are taking it as v in this particular problem. By any chance, even if you represent it as y0, y1, y2, it's not a big mistake. Okay, but this is very important. Substitution must be perfect. As you know, h value is 1 by 6, v0 value is 24.2, vn is v4, which is 39.4, 2 times v2 is 41.3, plus 4 times 35 plus 42, which is v1 and v3 respectively. Okay, we are making all those substitutions and then simplifying it. I am getting the value as S is equal to 25.41. Okay, which is approximately 25.4, let's say. Thus the distance traveled is 25.41 miles approximately. This is important because in our problem they have given velocity in terms of miles per hour, so the final value of distance will be in miles. Getting it? This is one of the, I would say, application problem of Simpson's 1/3 rule. Okay, here data set was not expressed in terms of x and y. Instead, they have expressed it in terms of time and velocity. Okay, so make sure whenever a data set is given and a numerical integration problem is given like this, first observe the data points and observe the value of n, I mean the last point vn or yn. We are supposed to apply the respective formula. Here n was multiple of 2, maybe in some other case it can be multiple of 3, 6, and you know accordingly we have different formulas. That's all for this session. Hope you liked it. Okay, thank you.